Good morning. Today we are working on lesson 7-3. For our math message today, you need to solve problem 1 on journal page 240 and be ready to explain your strategy. I have included the math journal pages in the module for you to look at while we're going through this. So number 1 says, find the area of the rectangle, report your answer in square feet, and be ready to explain your strategy. So take a few minutes and solve the area of that problem, and then restart your video. So the answer that you should have gotten is 46 3/4 feet squared. Now, you could have done this using several different strategies. The one that we have been using is using partial products. So we could have divided this up into sections and split up our length and width on each side. So this would be the 8, this would be the half. So we'd multiply the 5 times the 8, which would give us 40. That's the first partial product. Then we could have multiplied 8 times 1/2, which means put the 8 over 1, multiply straight across, numerators and denominators. So it would have been 8 divided by 2, which is equal to 4. So the area of this square is 4. Then we could have done 5 times 1/2. Same thing, put the 5 over 1. We get 5/2 for this one. Then here we're going to multiply 1/2 times 8. No, I'm sorry. 1/2 times 1/2. We already did that one. Which would give us the answer 1/4. So we're going to put that in this box here. Then we need to add all of these numbers together. These different areas, 4 plus 4, 40 plus 4, plus 5/2 plus 1/4, which is going to give us 44. And then we need to make a common denominator to add here. So we're going to change this to 4. We multiplied 2 by 4, or 2 by 2 to get 4, so we have to multiply 5 by 2, which gives us 10. Then the denominator will still be 4. 10 plus 1 is 11. So to convert that, 11 divided by 4, 4 goes into 11 2 times. So we're going to carry that 2 over to our whole number, and then we'd have 3 left, so we'll make that into a fraction, 46 3/4. We also could have converted all of the mixed numbers to just complete fractions and then multiplied those, which would have given us 7/2 times 11/2, which would give us a product of 187 divided by 4. Then we could do the division, and we would have gotten 46 3/4 feet squared as well. We could have also done a more tedious process of converting the dimensions to inches, and we would have had 8.5 feet equals 102 inches, and 5.5 feet equals 66 inches. Then multiplied 102 times 66, which would have given us 6,732 square inches, and then convert that back to square feet, which would have given us 46 3/4. Or we could have gone back to what we have done in the past and actually drawn tiles or small squares in the rectangle to count all of the tiles inside there to find the area of that rectangle. Now, if you remember, the formula area equals length times width states that the area of any rectangle can be found by multiplying its length by its width. Remember, previously we found the area of rectangles with fractional side lengths by tiling or sketching and counting smaller squares. Today we will use our understanding of fractions and mixed number multiplication to show that the area found by tiling is the same as the area found by applying the area formula. So imagine that the rectangle from the math message is a model of a kitchen floor. If I wanted to cover the kitchen floor with square foot tiles, how many tiles would I need? I would need 46 3/4 tiles. That's the answer that we found in the math message. Okay. The number of square foot tiles is the same as the area in square feet, and this number includes a fractional part. What does 3/4 of a tile mean? How could I cover 3/4 of a square foot with a square foot tile? I would have to cut the tile into smaller parts. So if I do not want to cut any tiles, what size tiles should I use? And how many of those tiles will I need to cover the entire floor? So you also see in your module that I included a copy of a piece of 1-inch grid paper. So use that 1-inch grid paper to draw a model of the kitchen floor and use that to determine the tile size that you could use. You may wish to cut out tiles of different dimensions from additional pieces of grid paper to test your ideas. When you have a solution, then press play again and we will continue to discuss it on here. So, if you draw out 8.5 units by 5.5 unit rectangle on the grid paper, you will find that since both the length and the width have a fraction of 1/2, I thought I could use tiles that were a 1/2 unit by 1 unit. I drew lines to split each square in half, like this. So these units would be 1/2 unit by 1 unit. I drew lines to split each square in half. There was still a piece in the corner that would require cutting a tile, so I drew more lines to divide each large square into 4 small squares, like this. The small squares are all 1/2 unit by 1/2 unit. Each large square represents 1 foot, so you should use 1/2 foot by 1/2 foot square tiles. So let me write that down here. 1/2 foot by 1/2 foot square tiles. So if you draw 8.5 units by 5.5 unit rectangle on grid paper, you can also look for the smallest piece. There would be a square in the corner that is 1/2 unit by 1/2 unit. I cut out a unit square and then cut it into 4 1/2 unit by 1/2 unit squares. I used one of the little squares I created to check that I could cover the whole area of my drawing with it. Without needing to cut the tile further, it worked. So you should use 1/2 foot by 1/2 foot tiles. Now remember that a unit fraction, let me write that on here. A unit fraction is a fraction with a numerator of 1. So 1/2 by 1/2, those would be unit fractions because the numerator in both of those is 1. So the unit fraction side lengths and multiple tiles fit in 1 square foot. So how many 1/2 foot by 1/2 foot tiles would I need to cover the entire kitchen floor? I would need a total of 187 1/2 foot by 1/2 foot tiles. I can find this out by counting the smaller squares along the length and width of the rectangle and multiplying them. you would have gotten 17 times 11, which equals 187. Or, since the smaller tiles fit in a unit square 4 times, you could multiply the area in square feet by 4 to find the number of smaller tiles needed. So our answer from before, which was 46 3/4 times 4, also equals 187. So 187 tiles are needed. So we were asked the question, how many half-foot by half-foot tiles would I need to cover the entire kitchen floor? So the number of half-foot by half-foot tiles needed to cover the floor is different from the area of the floor that we calculated in the math message. Has the area of the floor changed? No. Well, then why is the number of tiles needed different from the area? The area was reported in square feet. Square feet. And now we are counting tiles that are smaller than a square foot. How could we use the number of small tiles needed to cover the floor to confirm the area? Since 4 of the smaller tiles cover 1 square foot, we could divide the number of smaller tiles by 4. So, we said that it would take 187 half-foot by half-foot tiles to cover the area. So, if we take 187 and divide it by 4, and report the remainder as a fraction, we will get 46 3/4. Does this match the area that we found by multiplying the length and width in feet? Yes, it does. So you just found the area of a rectangle 2 different ways, by multiplying the side lengths and by tiling the rectangle with half-foot by half-foot squares. So, when might it make sense to think about tiles with fractional side lengths to find the area? Well, one answer would be that in real-world situations, sometimes it's easier to work with whole tiles or when we know the size of the tiles. So when might it make sense to multiply fractional side lengths to find the area? That would be when we just need to know the area in square units. So multiplying a rectangle's side lengths and tiling a rectangle with squares of fractional side lengths give the same result. Both of these are strategies for finding area. So what I would like for you to do now is to solve problems 2 through 5 on the rest of the Math Journal pages using the method of your choice. Be sure and show your work and write a number model to summarize the solution. So today, instead of including a video as I work through each of the answers on those Math Journal pages, I have just included in your module an answer sheet. So please take those, work through them just like we would in class, and then open up the answers, the answer key that I posted in the module, and see if you have done those correctly. If you still have questions after you've done those, please be sure and message me on Canvas or message me and ask if we can possibly do a Zoom session to go over that. I just don't want to make the videos super long to where it takes you a long time to watch them. So once you have finished that, make sure that you complete your math boxes for 7-3 and your home links for 7-3 and submit them in the proper places. And I will see you tomorrow.